Hi, I'm Rahul, reporting from the Fun Robotics Network, and with me here is Team 23251, who've had an amazing day at their San Diego Meet 2 with a very high OPR, an impressive claw intake system using a limelight, a claw transfer, and some passively sprung hooks. Learn more about their amazing robot on Behind the Bar. Okay, why don't you bring me in to show some of your drivetrain?
Sure. So last year we went for the full 18 by 18 inch kind of thing. This year we decided we wanted to be more fast and maneuverable, and so we decided to shrink that down to 14 by 14 inches, keeping it really small. So to achieve this, we obviously had to switch from our go build drivetrain to the parallel plate. So we have a parallel plate here, and we're running just standard mechanism with 435s geared down 6 to 5 for that higher top speed. And we also have these odometry pods, same ones we were running last year, except this year they've been slightly upgraded. They have metal plates rather than plastic ones, they're a bit more rigid. So I think we can move on from that.
Nice. Thank you so much. It's a really compact and unique drivetrain. And why don't you show me more about some of your intake system using that limelight camera?
Sure. So we decided this year to go for the kind of standard architecture. We got 2 slides. We saw a lot of teams be very successful with this last year, so we decided we were going to kind of replicate that. And so our horizontal sides has our intake. The intake is a claw. We kind of decided on this very early season and haven't changed it much since then. And then to facilitate actually lining that intake up, instead of having the driver do it, we decided that we were going to have some computer vision run here. And the reason for that is driver input can be imprecise. Computer vision is pretty much always pretty accurate, and so we have been using that, and it's been going really well for us. This also allows us to intake more reliably in auto, and so overall it's been a good decision.
Wow, that's really cool. I think it's really impressive that teams are using that new Limelight camera that was released this year. What advice would you have for some new teams that are trying to implement Limelight into their autonomous and teleop as well?
So give yourself a lot of time to work with it. It's there are some issues. It's a bit of an early stage product at the moment, so definitely give yourself time to work through those, and also make sure to update the software to whatever latest version is currently available, because the one they ship it with is not perfect.
Great, that's really cool about your intake. Why don't you lead into some of your transfer system, and if you can show some of that functionality?
Sure. So our transfer is pretty basic. One claw just kind of gives it off to the other claw. This claw closes, and then this can come out, and we can score on the high basket, low basket, or we have this extra degree of freedom here, the pivot, which allows us to score our specimens on the high or low rung.
Nice, that's really cool. And I think for a lot of teams, getting their transfer consistent and not having their samples fall into their robot, which can have a big impact on the rest of the match. How much iteration has gone into this transfer design? Has it just been a lot of CAD, or have you gone through a lot of different claw transfers? And talk more about that.
Yeah, so mostly this was mostly designed in CAD. I designed this very early season. It's been the same. We had sort of a early season bot that was not quite as good as this one, and then we kind of just carried the same system over to this, and it's been working out fine. Basically we haven't really changed much about it. It's been pretty reliable. One thing we did add this league meet, we, to stop samples from getting stuck inside our robot, added a little bit of a top cover here over our wiring, but other than that, not much has changed about this, and it's been pretty consistent.
Nice. Yeah, that transfer setup seems really clean and reliable. Now, why don't you talk more about some of your passively sprung hooks and how that leads you to score that level 2 ascent?
So very early season, we decided that level 2 ascent was probably the most we were going to get with our robot, as to get level 3, you need a pretty complicated system, and at that point, you're probably adding more weight to your robot, sacrificing your sample cycle times, so we decided we wanted to just go for a level 2. So we looked at what the world champions from last year did, Clueless. They had these hooks that were sprung with bungee cord, so we kind of replicated that with surgical tubing instead, because that's what we had. Now, one thing we noticed is that due to the presence of a bottom bar that wasn't there last year, obviously when you're climbing to that truss rung, what we had to do is we got these hooks to fold in order to actually get below that bar, because without that, the robot would just kind of brace against the bottom and wouldn't actually fall through, and we wouldn't score the ascent.
Nice. Yeah, I know getting over that second bar has been something that's gone through a lot of rule changes. The first bar has gone through a lot of rule changes and things like that. And how much effort, how much time have you guys spent in like tuning the lengths of the hang hooks, the power of the bungee cords, and things like that?
For the power of the bungee cords, one of our sophomore members designed these nice little tensioners that can be really easily adjusted. So we've just been using that to regulate that. Been pretty consistent and reliable. And in terms of getting the folding lengths right, we calculated this in CAD. We knew our CG is somewhere about here, and so we just split the hook down that, and it's been working fine.
Nice. That's really cool. And now, is there anything you would like to add about how your autonomous works or any software programs you guys would like to add?
So our autonomous has gone through a lot of iteration. So we started off with a 1+4, I believe, and we always knew that we wanted to have some sort of submersible intake during our autonomous, and this is definitely helped by the fact that we early on decided that we wanted to go with the limelight because that meant that it was going to be a lot easier to intake from the submersible. But then later on, when some other teams started showing off like a 6 sample instead, we thought about it a little bit more and we realized that it was actually a strategic benefit to go for a 0+6 because what would happen is a lot of teams would focus on one or the other and would need like the second specimen for their auto, and that's the reason why we decided to build a 0+6 for this meet. And then additionally, we also improved our specimen from last time. This robot was never actually initially designed to use specimen, but we were able to push it to be able to do specimen pretty consistently, and we were able to push it to do 5+0, although that's not entirely consistent yet. So that's still a work in progress.
Yeah, now another thing about your specimen auto, I've seen that you guys have opted to have the sample on the ground while other teams have had it on the wall. What decisions led to play into that idea?
So the main decision behind that was we just couldn't get this claw to rotate low enough to intake off the wall the way it's been designed, and we already knew we had vision alignment, which was probably better than what we could do with having the human player line it up by the clip, which can sometimes be a little bit, sketchy. So we decided that we were going to intake off the floor because our robot's designed to do that, and it passes through the specimens just fine. And with this extra pivot degree of freedom, we can score them pretty reliably. So we haven't had any issues.
Great, that's really great. Now, one last question. You guys' sample cycles are really amazing in the teleop period. You clearly spent a lot of time into driver practice. And what recommendations would you have to other teams? Like they've got their robot ready, but they just need to practice it and optimize it. What recommendations do you have to improve those cycle times?
So one thing I would definitely say for certain is look at what actions your driver is doing during the cycle. So we kind of analyzed that really extensively, and we found a lot of times where the driver was pressing unnecessary buttons or like doing some unnecessary action that put mental strain on them. So we decided that we try to use as much software as possible to try to mitigate those things. For example, if Krill here drives backwards, the slides will automatically come down. So he doesn't have to press a button to do that. It'll basically automatically do that. And we have all sorts of features like that that help take the mental strain off of the driver. Additionally, we also have one driver. Some people run 2 drivers, and we believe that one driver definitely helps because there is a bit of a communication cost between the 2 drivers, and that does slow them down sometimes.
Yeah, that's great. I think the discussion between one driver and 2 drivers is something that's really highly debated. And I think you guys really show that one driver can be successful. Now, one last question. There's still a couple months before the San Diego Regional Championship in March and the later qualification matches. What future improvements are you looking to add to this already great and fast robot?
So in terms of mechanical improvements, we're probably going to mostly keep things the same. We might make some things easier to swap out on the robot just because stuff does break. But other than that, I think it's probably going to stay similar.
And then on like some more software side, we want to definitely focus on reliability because especially towards the end of today, we ran into some issues that we didn't foresee, and those have caused us to miss samples and all sorts of stuff. So we definitely want to fix those issues. And then additionally, we want to have even more vision, and we believe that we can even automate even more tasks that the driver needs to do. And we're just going to try to keep pushing those sample times down.
All right, thank you so much, Team 23251 Triple Fault, for this amazing robot with their limelight detection and all of these cool features. And reporting from Fun Robotics Networks, this is Rahul, and catch you next time on Behind the Bot.